Here I have a question. If three equal circles of radius 3 cm each touch each other externally as shown, then find the area of the shaded portion. This problem was asked in second stage of NTSE 2014 as a question 71 in Chandigarh. If you want to go through the question paper, I have put the link in the description for your reference. Before beginning with the solution, I will discuss two formulae related to area of triangle and circle. Now, the first formula states that the area of an equilateral triangle is given by root 3/4 times side squared. So consider a triangle ABC whose each side measures a units. Then the area of triangle ABC is root 3/4 times a squared. Now, the second formula states that the area of a sector of circle is given by theta by 360 into pi r squared, where theta is angle subtended by sector at the center of circle. So consider a circle with O as its center. We will draw a sector subtending an angle equal to theta at the center. Then the area of sector is theta by 360 into pi r squared, where r is the radius of circle. We will begin with the solution by first marking out the center of each of the three circles. Now, according to question, the three circles are congruent, so each of them will have a radius r equal to 3 centimeters. Next, we will draw in the radii of these three circles through their centers, and notice we are going to form an equilateral triangle with a side length of 2r. This means each angle is equal to 60 degrees. Now we will solve for the area of the shaded region by subtraction. We will take the area of this equilateral triangle, and then we will subtract out different sectors of the circles. So we can set up an equation that the area of the shaded region is equal to the area of this equilateral triangle minus 3 times the area of a sector. Here 3 times the area of a sector signifies that the three sectors have equal area since they belong to congruent circles and have same central angle subtended at the center. We now begin our simplification. The area of an equilateral triangle is root 3/4 times its side squared, and the area of a sector is theta by 360 times pi r squared. We will substitute this formula in our original equation. Next, we will put the value of side of the equilateral triangle as 2r, and the central angle of the sector as 60 degrees from the figure. This simplifies to give root 3/4 times 4r squared minus 180 by 360 times pi r squared. On further simplification, we get root 3 times r squared minus pi upon 2 times r squared. Then we will take r squared as common from both the terms. Finally, we will substitute r, which is the radius of the circle equal to 3 centimeters, and take half as common from the terms inside the bracket to get the final and simplified result as 9/2 times 2 root 3 minus pi centimeters squared. Therefore, we have shown that in the given figure the area of shaded region is equal to 9/2 times 2 root 3 minus pi, which is approximately equal to 1.451 centimeters squared. Thanks for watching.